6-5, linear inequalities. So objective for this section is to first talk about what a linear inequality is and how to graph a linear inequality into variables. Then we'll use linear inequalities when modeling real-world situations. So a linear inequality in two variables has an infinite number of solutions, just like a regular inequality. So when we were dealing with inequalities previously, we would have something like x plus 2 is greater than 3. Okay? That has an infinite number of solutions, right? We would subtract 2 from each side, and we have x is greater than 1. There are an infinite number of things that we can plug into x that are greater than 1. So the same is true with a linear inequality with two variables, something like that. Okay? These solutions can be represented in the coordinate plane as a set of all points on one side of a boundary line whose equation is represented by our inequality. So a linear inequality in two variables such as y is greater than x minus 3 can be formed by replacing the equal sign in a linear equation with an inequality symbol. Greater than, less than, greater than or equal to, less than or equal to, any one of those four. A solution of an inequality in two variables is an ordered pair that makes the inequality true. So what does that mean? Okay, so let's see, is the ordered pair a solution of y is greater than x minus 3? 1 comma 2. Well, remember that that is the x coordinate, that is the y coordinate. So all we have to do is plug them into the equation and see if we have a statement that is actually true. Is 2 greater than 1 minus 3? Well, 1 minus 3 is negative 2. 2 is greater than negative 2. Let's look at this next one. Negative 7 is y. Is that greater than negative 3 minus 3? Negative 7 and negative 3 minus 3 is negative 6. That is not true. Negative 7 is not greater than negative 6. So this point is a solution of this linear inequality, while this point is not. And we'll talk about what that means in a second. Okay. Is 3, 6 a solution of, well, let's see. 6 is less than or equal to 2 over 3 times x, which is 3, plus 4. And remember to multiply a fraction by a number, right? We can put this over 1, multiply the tops, multiply the bottoms. These two can reduce. So it is actually 6 is greater than or equal to 2 plus 4. So that is true because it says or equal to. Reasoning question, suppose an ordered pair is not a solution of y is greater than x plus 10. Must it be a solution of y is less than x plus 10? And this is a tricky question. So you would think it either has to be greater than or less than. The answer here is no, because in order to be a solution in one set or the other, they have to be completely opposite. Greater than or less than, it doesn't say anything about equal. Okay, so if one of these said less than or equal to, then yes, if it's not a solution in the first equation, then now it must be a solution in the second one, because that covers everything, right? Something can either be bigger than something or less than or equal to something. There's no other situation that we have. But for this one, a point could be equal, both of these, and it would be true. It's just not true in both. Okay, so let's talk about what being a solution means and how to graph these linear inequalities. The graph of a linear inequality in two variables consists of all points in the coordinate plane that represent solutions. The graph of a region is called a half-plane that is bounded by a line. All points on one side of the boundary line are solutions, while all points on the other side of the boundary line are not solutions. So basically, we're going to use our graphing techniques where we have the slope, where we have the intercept, and we're going to graph these boundary lines, okay? Now, as soon as we see our inequality, okay, we're just going to pretend, we're going to deal with that at the end, and what we're going to do is graph this just like a line and then decide which side of the boundary line to color in, okay? If it is a less than or greater than, right, we're going to use a dash line, and less than or equal to or greater than or equal to, we're going to use a solid line, okay? And my answers are going to be half of the coordinate plane. That's why it's called a half plane. Okay, so what is the graph of y is greater than x minus 2? So first, we're going to graph this boundary line, that y is equal to x minus 2. And we're going to draw it with a dotted line, okay? So the graph of y is equal to x minus 2. My slope is equal to 1. My y-intercept is negative 2. So I'm going to put a dot on negative 2. And I'm going to go rise over run. I'm going to go up 1, right 1, boom, boom. And here is, and then down 1, left 1. And so there is my line. Now, because it is a greater than inequality, not greater than or equal to, I'm going to make this line with dashes, not a solid line. Okay? And there we go. Now, I need to decide which region to shade in. Which side of the line should I shade? Which side of the line should I leave blank? And there's two ways to do this. The first is to find a test point. Okay? 0, 0 is a good one. Usually, unless it's right on the line, usually that's the one you can use for any test point. So let's see, is 0, 0 a solution? Okay, so we're going to plug 0 is greater than 0 minus 2. Is 0 greater than negative 2? Well, the answer to that is yes. That means this point right here is inside the shaded region. So I'm going to shade all this side. Okay, that is the shaded region. Okay, and so my half plane, the answer is all of this space over there. Okay, and of course we can shade this a lot better with some fancier techniques. We'll do that on this one. Okay. What is the graph of y is less than or equal to 1 half x plus 1? So I'm going to graph y is equal to 1 half x plus 1. My intercept is 1. My slope is up 1, right 2. And because it says or equal to here, I am going to make a solid line. And let's make a couple more points so I make a nice line. And not quite perfect, but we get the idea. Okay, so now let's plug in 0, 0, and we're going to say that y is less than or equal to 1 half times 0 plus 1. That's why it's nice to use 0, because anything times 0 is 0. So 0 is less than or equal to 0 plus 1, which is 1. Is that true? 0 is less than 1. Yes, it is true. That means that is in the solution. Okay, so I'm going to shade. I'm going to use my little smart notebook tools here. I'm going to shade this whole region. And let's shade it blue. Didn't work. Oh well. Okay, we're going to shade this whole region right here as my answer, my half plane. Okay. An inequality in one variable can be graphed on a number line or in the coordinate plane. The boundary line will be a horizontal or vertical line. So another way, or a different type of equation that we're going to get is a linear inequality with only one variable, the x or the y. Okay, so for these, my line is going to be either horizontal or vertical. So if I graph the line, the boundary line is going to be x is equal to -1. Okay, if x is -1, that's where x is -1, y is 0. X is -1, y is 1, 2, 3, 4. So we can see we're going to get a vertical line. I want to make it a dotted line because it just says greater than, not greater than or equal to. And then I have to ask myself, which side do I shade? Well, I could always plug in 0 for x, which is right there. Okay, is 0 greater than -1? Yes, so I'm going to shade to the right. This works also with y is greater than or equal to -2. So the boundary line is y is equal to 2. Okay, if y is equal to 2, there's 2, 0, or 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, and you can see we're going to get a horizontal line. And now, because it says or equal to, I'm going to make a solid line. And is 0 greater than or equal to 2? No. So I don't want to cover up 0. So 0 is right here. I don't want the boundary to cover that area. So I'm going to shade above the line. And let's finish our got it problem. X is less than -5. Whoops. X is less than -5. So we are going to go with a dotted line at -5. And less than, I want X to be getting lower. 0 is not less than -5, so I don't want to cover in 0, so we're going to cover in this area right here. Let's clear off the graph, and let's do y is less than +2, or sorry, less than or equal to +2. So my line is going to look like this, and I'm going to shade in the bottom region right down here. Okay. When a linear inequality is solved for y, the direction of the inequality term determines which side of the boundary line to shade. So this is another technique that we can use. Instead of plugging in 0, 0, okay, instead of plugging in 0, 0 like I did here, okay, I could look at this equation right here and say, because this is greater, okay, I want the shading to be greater than the line. So I want to shade above the line. Because this one was less than or equal to, I wanted my shading to be below the line because I want the shading to be less than. So that's another way to think about which way to shade your inequality. So this says if the symbol is less than or equal to, shade below the boundary line. If the symbol is greater than or equal to, shade above the boundary line. Sometimes you must first solve the inequality for y before using the method described above to determine where to shade. Okay, let's look at a word problem. An interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown. We got tiles, and then we got wallpaper. The owners can spend 420 or less. Write a linear inequality and graph the solutions. What are the three possible prices for the wallpaper and the tiles? Okay. Well, first, we're going to need to make an equation. So let's let x equal cost for the cost for wallpaper, and let y be the cost for the tile. Whoops. Okay. So my equation is, we have 12 and 24 square feet. So we're going to find the cost per square foot. And we want our cost, when we're done with it, to fit in our budget, which means how much we can spend, okay, or less. So usually when you're doing a remodel, you do have some sort of amount of money that you're able to spend, and you have to spend less than that. So first, let's go back up a little bit. We have 24 square feet of wallpaper times the amount that costs, plus 12 square feet of tile times the amount that costs. I need this to be less than or equal to $420. Okay, in order to graph this, let's get y by itself. So let's subtract 24x from both sides. We have 12y is less than or equal to negative 24x plus 420. Divide out the 12, and y is less than or equal to negative 2x plus 35. Okay. So let's now think about what this graph would actually look like. All right. So when we make a graph, right, we know that it's going to have an intercept of, let's make this 5, 10, 15, 20, 25, 30, 35. So we're going to go by fives. 10, 20. It's not going to be perfect, but we'll get the general idea here. And let's the bottom go by 5, 10, 15, 20. Okay? So we're going to start at, whoops, 30. This one's 30. We're going to start there, and we're going to go down 2, right 1, down 2, right 1, down 2, right 1, blah, 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 blah. All right, and so we're going to get 5. At 5, we're going to spend about $25. At 10, we're going to spend about 15. At 15, we're going to spend about 5. And somewhere over there, we're going to have nothing. So here's about what my graph is going to look like. Not perfect, not exact, but we get the idea. And we're going to shade because it's less than or equal to, we're going to shade this region right here. So somewhere in there is the amount of money that we're going to spend. Now this graph only makes sense in the first quadrant because it's not really possible to buy a negative amount of wallpaper or a negative amount of tile. So I don't have to keep going. I don't have to make a graph, you know, in the second and any of the other quadrants where x or y is negative. So now we just need to figure out how much they want to spend. So the three possible prices, the square foot of wallpaper and tile, are numbers that work out kind of kind of well here. So we can spend $5 on wallpaper. So we can have 5 and 25. We could have 10 and 15. Yeah, 10 and 15. Or we could have 15 and 5. All those should work. You can have any really combination here. Anything inside this thing right here would really work. If you check these, both of these numbers should work into this equation that they're less than 420. And ideally, you want to kind of be equal to 420 because you don't want to have money left over, or maybe you want to save some money. But same setup here. I just want to set this one up for a party. You can spend no more than $12 on nuts. Peanuts cost $2. Cashews cost $4. So we would set this up as, there's my limit, 2x plus 4y is equal to 12. Getting the y by itself, whoops, equals, I always do that, less than or equal to, right? We want to spend less than or equal to $12. Negative 2x plus 12, divide out the 4, and we get negative 1/2 x plus 3. Graph, figure out how many x's you want to buy, and that'll tell you how many y's you're going to buy. All right, let's wrap this up with looking at a picture and figuring out what the equation of the graph is. And to find the equation of the line, I need an intercept and a slope. My intercept is 1. My slope is up to, right, 1. The boundary line is solid, which means we are going to use an or equals at the bottom, and I'm shading below the line, which means it's going to be less than or equal to. So putting that all together, y is less than or equal to 2x plus 1, which is a. Let's look at that again. Writing an inequality from a graph. The boundary line is dashed and has a slope of 1/3 and a y-intercept of -2. The area above the line is shaded. Dashed, which means above the line with no equal sign, slope of 1/3, y-intercept of -2. And there is my inequality. Our lesson check, find out if something is a solution, plug it back in. We can graph these linear inequalities by graphing the line, shading below the line, with a shading below the solid line, and shading below the dotted line. The the inequality right here is going to be y is less than up 1, right 2, 1/2 x minus 1 for the intercept. How's a linear inequality in two variables like a linear equation in two variables? Same techniques. You're going to graph the line. Just a linear inequality, you're going to shade above or below. To graph the linear inequality, do you shade above or below the boundary line? Below, because it's less than. Right? An inequality that describes the region of the coordinate plane not included in that graph. Okay, well that's just the opposite. So y is greater than or equal to 5x plus 1. This shades below and does not and has a dotted line. This shades above and has a solid line. So it includes the solutions on that one. And that was 6-5 linear inequalities.